wanted, right? So when Rama sent us this talk, right, I and Bharat had we just fell in love with this topic, and we were so much looking forward to what is the content and what was the abstract and what all stuff we will be learning as part and parcel of this talk. And then Rama came up with a nice bit of slides and a bunch of demo. Guys, just stay tuned to this and enjoy the talk.
My name is Rama. I'm a PostgreSQL database consultant. I'm working in Pythian. So I provide customized database solution for, especially I'm specialized in database migration, and I will do the code refactoring part and performance tuning, and obviously the DBA part like monitoring, installation, and all the stuff with respect to Postgres. I'll do that stuff. So, and also expertise in handling Postgres in different environments like AWS, GCP, Heroku, and obviously in on-prem different environment. I explored Postgres. So, before I go into my topic, I would like to tell, so you may be a Postgres SQL DBA, but as per the current scenario, you should not restrict yourself to database alone. So if you want to implement something, you have to think as a holistic approach. Like you have to implement the use case scenario. Like olden days, we will the DBA team will do only the database coding, development, and those things. If anything related to application, we will push that work to app team. So because that time we don't have enough training material to learn those stuffs. But in the current situation, we can implement anything. So as with the OpenAI, you can get code of whatever features you want, and also you have in Google Colab, you have so many use cases implemented, and you are open to access the code of in GitHub. You could access any code. So if you want to implement something, you implement end to end, so that you will get confidence and you will get more interest to implement so many use cases. So for today's scenario, it is about AI. Why I have chosen being a database person, I have come up with a topic like pgvector. This is one of the features of Postgres. Along with that, I have think about it in a holistic approach, like end-to-end process to implement the scenario, not specifically to pgvector. You have to implement so-and-so, these are the syntax. I'm not going to explain like that, but holistically how you can implement some search engine. Even in my demo, I'm covering some search engine, which is similar to my day-to-day activity, what I have come across, similar to that. So first, even here, you could not understand the pgvector directly. So you could not blindly install, create extension and do querying, and those things you are not going to do. You must understand what is AI, how that AI is linked with PostgreSQL. That is what you are going to see. So first, before going to pgvector, you must understand these terms of AI to know how PostgreSQL is helping to store and access the machine learning data into our database. So first is machine learning. So you people might have heard AI for more than a couple of decades. It was there even when I was even I studied in 2007. I studied about robotics and AI technology in my college syllabus. But after that, I never see AI and those stuffs in my day-to-day IT field. Even though I was in 15 years of field, I don't get much involvement with AI and those things. But if you take the after the evolution of machine learning, recently the machine learning process, it started it started making the system unsupervised learning. So being a human, we will learn something on our own, right? The same way, the system is without coding, it is learning the things. So for that is what the unsupervised learning mechanism create. So, I mean, it opened door for many ideology and many implementation process, those things. So that is why after the ChatGPT and those detailed invention, we started looking at pgvector and how we can use it in our database. So if you take machine learning, it is a powerful tool which can able to make automate the task and make decision processing. So those things it can able to do. So before, those are the activities can be done by some of the things, like it is internally it is doing some semantic search and it is having some algorithm to do such task. So if you take one of the main term here is semantic search. So generally in older days how we will code is, if I want to learn something, if you want to search about something, if I search fruit, it will give only the fruit output or something. But if we tell fruit to one human, they will tell fruit means they will start linking it with apple, orange, apple juice, orange juice, and some like once they started saying about juice, they will think about Pepsi, Coke, like that. Our mind will think so many things and link it. The similar way, the semantic search, what it is doing is, if we search something, it will find the meaning of that word. It is not finding that word as keyword. What are the words interrelated with that meaning is, it is gathering those information and providing all the details. Suppose if you search male, then it will start linking male may be a man, father, son, like that. It will start linking everything and it will grouping that data. That is where it is very helpful for the machine learning, unsupervised learning of machine learning. So how it is doing is with this semantic search kind of algorithm only. It is grouping the data. If you provide some hundreds of data, millions of data into the database, it start grouping the data for you. It is thinking like human. So if you want to do something, we will be grouping the things. If suppose you want to arrange something, you know which things go to which place, those things you will be aware. The same way, the machine is doing the things. It is grouping the data based on the semantic search. Even it do not know what the data is, what it is going to be. It don't know your use case and all. It is grouping the data based on the contextual meaning of the data. It is having kind of dictionary. It is linking the data. And with normal search means it is our normal keyword search. If I employee name equal to Rama means the data Rama will be extracted. So it is also just for comparison I have put. And we have another approach, exact nearest search. So exact nearest search is, if you query the database, it will find the nearest data points in the vector space. So in the vector space, the data will be, data points will be there. Based on, it will group your data and have data points for each of your data. So that grouping, how we are going to query that grouping, for that only we have two methods. One is exact nearest search. What it will do is, it will go and search the data point for your query and collect the information related to the data points. So similarly, the approximate nearest search, what it will do is, it will not go and find a data point nearest to your query. It will go and check kind of index. It will go and check the centroid of that data point which is nearest to your data. That it will cumulate the data related to the data points. It will not go and search all the data. Next is L2 distance. L2 distance means it measures the distance between two data points. If you know Hyderabad airport to this office, how much is the distance? So that is what calculated in L2 distance. It is nothing but the Euclidean space or Euclidean distance formula we have in geometrics. This page. So this is what I said, right? It will group the similar data in the vertex database. What it will do is, if you input some data, I mean millions of data, it will group the data like this based on the similarity. If you take here, it is grouping. See, walk, run, diet. Those are for health conscious. Those are similar. It is grouping the data. The same way, pizza, burger, and biryani. So those are food item. It is grouping the data. The same way, it is grouping the similar data. If you take walk and rows, there is no similarity between that. So it is putting the data far away from that data group. So similar data will be grouped in some point. Dissimilarity will be put in some other data point. So embedding is nothing but the numerical representation of data. How it is calculating the numeric is this picture. Like it will create the XY dimension. Likewise, in the real world scenario, we will be having n number of dimension. For the in the dimension, it will fix all your input data and find group the similar data and find the numeric value for the same. In the dimension, what is the numeric value for that data? That it will figure out and provide the data. If you search this paragraph in your database, it will take more time. Maybe it has to search therefore in a database like that. It has to search each and every word. But with embeddings, what we are doing is, we are converting this paragraph into numeric number. So comparing numeric number will be much faster than text search. So that's why with embedding we could fetch the data, or finding the similarity between data is much simpler compared to the large volume of data. So another one is K-means clustering. K-means clustering is nothing but it is one of the machine learning technique for unsupervised learning, I said, right? So using this K-means clustering algorithm, it is doing that work. What it will do is, it will group your data, like it will group your similar data together, and it will find the center point for the data, I mean mean value for the data, that whenever you query your data, it will not go and search, compare with all the fields. It will compare only with the center point. You can consider the center point as category. So it will go and search only in that category, not in all the data and all the categories. So likewise, we are simplifying the process. I mean, the search pattern we are simplifying, and the similarity search, with that we are getting the similar data as well as fast. It is retrieving the data very fast. Next slide. So this is how, so if you are taking some AI use case, this is how you have to process your data. So this is a sample. In the real world, you may having many steps, but for my use case scenario, I have taken one use case, AI use case. For that, I have done these steps only. What I have done is, first I have defined the use case. I chose the use case which is relevant to me, like cooking and recipe related things. I chose one use case. After that, I want the data for implementing that use case. So I just verified I have the data set for that use case. Once I retrieve the data set, and I will finalize the data set. The data set may be of from vague data. So I have grouped the data and make it finalized for my input. So this initial data processing will be only for setting up your initial AI database. So once it is done, it will be the regular process will be like that only. Once you import your initial data, then it will go to the AI application. AI application is nothing but the Python code that will send. What it will do is, it will take all your input data and convert the data into embeddings. I mean your data to numerical format, and it will, the embedding data will be stored into your database with pgvector extension. So PostgreSQL pgvector extension, how this, so for storing that embedding data, we are having many vector databases. So that will be store or handle only the vector database. But with the RDBMS, you need not go and learn or implement new vector database on those things. With existing RDBMS database itself, you could store your vector data just by creating one of the extension pgvector. So just by creating that, we are having the feasibility of RDBMS and vector data together in our environment. So our use case, we can think, we are open to choose a use case which will be up for RDBMS and vector database. So you are using both the database features, and after that it is mainly used for recommendation system and image search process. pgvector extension is supported from version 11 and above. The latest version of this is 0.4.4. And also it is supported in all cloud provider vendors like AWS, Azure, GCP, and Timescale everywhere. Next slide. Vector. So you are, like Naresh said, you have to go and see what that if you are doing something, what it is internally doing it in the database. So if you create the pgvector extension, it will first create the type called vector. So that is the data type it is adding to store the embedding data, and after that it will add few functions that will be helpful to analyze our data, and the storage relevant part. So it is allowing the extended storage for our database vector, and this is a calculation for how much data we can store. And it supports three main operators, like one is Euclidean distance. What it will do is, it will find the distance between 2 points, and the inner product will have some, these are geometric formulas. With that, by applying that, it is finding the data. So this is a formula for everything, like Euclidean distance means it will consider your vector data like this. So if you want to find the distance between two data points, it will find the distance with this formula. By finding the distance, what we are going to do? So by finding the distance, we are going to find the data are similar or dissimilar. So the data with lesser distance will be considered as similar data, and the larger distance will be considered as dissimilar data. Next slide, sorry. So these are the functions which is supported in pgvector. One is cosine distance. This is also one of the distance method. Similarly, we have three distance method. For all three methods, we are passing the vector as input. So where these three method will be helpful is, if you have a use case, but you don't know which distance method will be apt for your scenario. What you can do is, you can take two sample input and pass it to the function. Then it will give the result. I mean, distance of two similar data. You can find which method is giving apt distance which you are expecting, and also the time taken to provide that, calculate the distance. So with that, what we are doing is, we can, with these three functions, we can compare and decide which distance method will be apt for our use case. So for that only we can use that. After that, if you have the vector data, but you don't know the dimension, then you can pass that to the vector dimension function. It will give now how many number of dimension we have that function. After that, we are having average and vector norm functions. Next slide. This is, as I said, we have exact nearest search and the approximate nearest neighbor search. So with these two search, how it is working in pgvector, that we are going to do. First one is, the exact nearest search will find the nearest neighbor by giving the query, two data points, whichever is nearer, that it will find. But the approximate nearest search, as I explained earlier, it will find against the centroid. It will not go and compare it with each and every data points. And by default, pgvector extension without index, if you search with pgvector, by default it support exact nearest search. If you want to use the approximate nearest search, then you have to create index. So then only you could use that function. After that, the recall rate will be high with exact nearest search. What it will do, recall is nothing but the percentage of accurate result we are getting. So the accuracy will be perfect with exact nearest search, and with the approximate nearest search, the accuracy will be not perfect as such exact nearest search, but the response time will be fast. The last point I have miswritten, like exact nearest search will be slow and the query response will be slow, and the approximate nearest search query response will be fast, because it is not comparing all the data. Yes. So K clustering. So what is K clustering? Can you go to the nest? Yeah, so K clustering, how the K cluster working is, so you are having your data points. I mean, you have fixed your data points into the X dimension, whatever may be your dimension, you have fixed your data point. Once you fix the data point, what you are doing is you are grouping the data as a region. So you will be splitting the data and grouping this as region. After that, you will add a center point, that is called centroid. You will add centroid for each and every data group. So whenever we query the database, it will go to the in these four or five data points, whichever is more relevant, I mean whichever is having less distance, that centroid will be taken, and the data around that centroid will be written as a result. So this is how the K clustering works. Next. Okay, while creating if you are importing data, then that time the system may not know, because it is the unsupervised kind of data. So what it will do is it will go and fix your data in different clusters. So we have to input our data, then only it could group the data and find the centroid and make your search perfect. And after that, we are having we have to give the number of region with the list parameter. If your table is having 1 million rows, then you can go with rows divided by 1000. These are formulas they have given. And recall percentage can be improved by using the probe and list number of list. After that, we are having partial. We do have option to create partial index with pgvector. So what are the pros and cons of using pgvector? So you can easily implement that in your environment. Like you don't require the vector database or vector database specialist for your data. With your existing PostgreSQL environment, you can very well easily set up the vector database. And it is supporting, you can think of a use case which will support both RDBMS and vector database. So you have more option to work with that. And these are the features like data integrity, and those things can be are the features of PostgreSQL that we are using in our vector database. So with the large volume of data, we have more scope to use our PostgreSQL database. And we are open to link our database with, connect our database with any database language, because PostgreSQL can be connected from any programming language, so we can easily establish the connectivity. After that, it is supported in all the environment, major cloud vendors and on-premises. So the cons, what we are having is, in this we are supporting only IVF flat method for index creation. Apart from that, the other dedicated vector database have different vector method for querying the data. After that, it is having it is supporting 16,000 dimension, but you could index only the table which is having 2000 dimension. If you are having more than 2000, that could not be indexed. You can use only exact nearest search in that scenario. After that, if you are having more than 16,000 dimension, then obviously pgvector is not the correct vector database for you. Okay, these are the installation step, demo files. The performance of querying that embedding data. It will not do the conversion of embedding and all. For that, what you have to do is, you have to use tools like OpenAI, Vertex AI for converting your actual input data to embedding data. So even in OpenAI, it is supporting. It is giving $5 credit. I mean, once if you want to do some POC or something, they are giving $5 credit. You can use that for testing your data. So next. So with OpenAI, I have provided the data, input data, and got the embedding data as output. What I'm doing is, I'm creating a table and importing the data to the table. And here, yeah, stop here. So this is my data. So this content, for this content only, I have created the embeddings. What I'm doing here is, I'm searching the recipe spinach stuffed chicken. So what it will do is, it will find the similar kind of ingredients what other recipes are having is, it will fetch that data. If you see the main ingredient for all this is chicken, by using that semantic value, it is fetching the data. Like if you see the other ingredient, it is having other input data. So by using semantic, in this case, if you see, it is kind of a keyword search, but for other examples, you could see the semantic thing. The same query I'm executing with a different distance, left side. So different distance method. If you see here, here I'm using the distance method. It is inner product distance method. For my use case, for all three methods, I was getting the same output only. There is no change in the output for that. But maybe for different use case scenario, it will vary. If you take some image or video recording as your input, for that use case, it may differ. Down. Yeah. Same thing, with cosine distance, I'm calculating the same spinach chicken as the input and getting the similarity data. Next. See, I just want to get the totally opposite data. See, I'm giving spinach stuffed chicken as input. I just want something which is irrelevant to this input. So what I'm getting here is, if you see crackers, with crackers, I could not do anything. Right? Strawberries. With chicken, I could not use strawberry, apples, and those things. So that is what it is creating, getting the opposite data. So likewise, you can create your use case and test the different scenario for your use case. Next, the same way, I am just formatted the output to see if it is kind of chatbot kind of implementation, then you can use it. So what are the ingredients for palak paneer? If I ask that question, it will give this answer, palak paneer, what is the ingredients it requires, as well as the similar data like matar paneer, paneer tikka, rasmalai, samosa, those details also it is fetching based on ingredient details. Next. Here I am searching with BBQ. If I search with BBQ, you see stir fry, there is no link. So it is the mushroom stir fry, like beef, broccoli, like that. It is based on the similarity things, it is fetching the data because the vegetable oil and soy, here BBQ sauce, but sauce is common. So based on that, it is fetching the data. Same thing, I'm searching with the orange, but here I'm not getting the expected result. I'm searching with the orange, but it is providing me orange chicken. So I'm expecting something relevant to fruit, but here giving orange chicken, orange juice. Remaining results are chicken related. So these are even though you have the use case and your expectation is different, you are getting different data. What you have to do is, likewise you have to test your data. So with different iteration of testing, you will know your use case is providing the expected result. There may be chances like this for getting invalid input. You have to correct the data, or you have to see what is the different vector method, I mean distance method, to evaluate which method is providing the correct result for you. Next. Now I am searching the orange juice. So here now it is getting Similar things like fruit salad, lemonade. So those are juice kind of. This is what I expected in the previous. But it was providing chicken and those things. Here it is giving juice and lemon juice. But it is fetching something like watermelon salad. With salad, it is fetching the similar data. Cheese is common, like that it is fetching the data. And if you see watermelon and cucumber are common ingredients. Both are water content. Both are water content. And likewise, it is fetching the data. So how the machine learning is thinking and fetching the data like humans. So that, like this is just simple example. Everyone have different approach and open to test many things. You can implement so many things and do the POC to figure out different scenarios. Same way. These are the, whatever I said is the functions I earlier mentioned. So I said, right, with cosine distance, I'm using the same input, like orange juice and the fruit salad as an input for all three methods. If you see, that's it. I'm seeing the distance. With that, I can compare which method is giving me same distance. I mean, smallest distance, and also how much time it is taking to evaluate that distance. So based on this, you can compare and decide which method will be apt for your use case scenario. So for comparison only, I have put all these three. Can you go further? Can you scroll down? This is nothing but just I'm creating the index. Can you scroll down? So after index creation, what you can do is you can see. So I said, right, the storage is the extended method and it is using 1536 as extension. I have created all three index method. So I have created all three, but my data didn't use that one. After creating index, you have to check with the explain plan, your index is used or not, that you have to validate and decide. But my use case is having just 399 data. pgvector is capable to handle 1 million record and more than that. So that's why my use case didn't use the index. Planner is always choosing sequential scanner search. I could not produce that one, but with more data, you can attain the index scan also here. That's it. Yeah. So, can you open the inside? Different use case with the data or input which I have provided.
Already using
No, I just explore this one. No customer is using. Just git clone. You are cloning the. Excuse me for you. So you are cloning the data. After that, just clone. Have this output. That's it. The second step is I'm just checking the pgvector directory is cloned and it is available in my system. After that, I just switch to the directory and running make install. That's it. Nothing else. You are just cloning, make install. That is finished. What you have to do is you have to connect to your database and create extension vector. You are ready to use your vector database in Postgres.
Evaluate the accuracy of the output when you're trying to use this. Is this something that you can train and model the data and then try to reach the accuracy more and more as you have the data growing actually? So is it something that can be tweaked or
as I said, that clustering method will fix the data in different places, different region or something. What you have to do is you have to do the re-indexing on your table to make it up to date and use the data. And apart from that, data-wise, it is up to your use case to decide your data is up to date or it is growing or having the required output. You can have some jobs to check, is it producing the same result like previously while you were installing. Like that, you can do some trial and error to check or continuous monitoring. Like monthly once you can check your after data growth, it is working or not.
Rama, I have a question. Yes. There are many kinds of distances, right? So when do you choose cosine distance, or when do you choose any kind of distance, or can you choose anything? Or how do you make that decision?
Use case, I have compared the all three method, whichever is producing the less distance. But in general, what they are explaining is, if you are having image kind of input, then cosine distance will be the best option, because it will not see the distance. It will see, is it in the same angle? Like 0 means most similar. Even though it is having more distance, it will consider that as a similar data. So if you take the Euclidean distance, that for test search and those things, based on the semantic only, test search embedding will be created. So that the distance will matter. So for that one, for test search, I would recommend to use Euclidean distance. For image search kind of thing, cosine distance will be a best option. But with different scenario, you have to test and see which one is apt for your use case.
Perfect. So the other question, the follow-up question is, like, when you are building an entire K cluster, do you think that there is a difference between a cosine distance and a Euclidean distance when a K cluster is built?
I'm not pgvector, your indexing method using the K clustering for arranging the data. I was just explaining how the K clustering is used for creating the index. I'm just explaining that scenario. Even that index, you are having cosine distance, Euclidean distance, and dot product. You have all three methods for the index, but you again it will be a POC to test which one is apt.
So depending on that, the K cluster is an internal operation that gets formed.
Yes.
Okay, fine. Thank you.